If you look closely at almost any complex modern system, maybe it's a piece of machinery or even just a sleek architectural feature, you start to see this hidden hero, the aluminum extrusion. But we're not just talking general structural stuff today. No, we're doing a deep dive into something much more specific, the world of hardware profiles. We've got some really great technical sources you sent over, focusing on how engineers, designers, how they actually select these things. And our mission really is to give you a shortcut to understand why these specialized profiles are so key for strength, for lightweight performance, and maybe more importantly, those specific factors, beyond just size that make or break an application.
It's absolutely critical. People talk a lot about aluminum extrusions,
Right.
how versatile they are, strong, light. But when you go from just holding something up, like a frame, to actual hardware that needs to function, well, the margin for error basically disappears. That's exactly why these specialized profiles exist. Your standard off-the-shelf stuff, it just doesn't have the necessary precision.
Okay, precision. Let's unpack that. What exactly makes a hardware profile different? How do we distinguish it from, say, a regular aluminum beam?
Right. So hardware profiles are really a distinct category. They're extrusions specifically designed to do something mechanical, something operational. That's the key difference. A structural profile, it supports load. A hardware profile, it has to, interact, move, connect. Think about hinges, for example, or handles, tracks for sliding doors or panels, even locking mechanisms for enclosures. These are functional parts. They have to move smoothly, integrate perfectly.
Ah, okay. So if a standard frame is a tiny bit off, maybe it wobbles a bit, no big deal. But if a sliding track profile is off by just a fraction, the whole thing could jam.
Exactly, or wear out incredibly quickly. That's why the technical demands are so much higher.
So what are those specific demands? What drives the need for custom solutions here?
Well, because they often interface with other moving parts like bearings, locks, seals, other profiles. You absolutely need exact dimensional accuracy. That's non-negotiable. The sources really hammer this home. You also need a perfect surface finish, really smooth, to minimize friction, prevent wear. And then there's compatibility. Guaranteed compatibility with everything else that touches the fasteners, the adjacent parts.
Makes sense.
And often they need extra work after extrusion, like precision machining, maybe specific drilling patterns, special surface treatments, all tailored to the specific job it has to do and the environment it'll be in. High vibration, chemicals, heat, that all matters.
Wow, okay. That does sound like a lot to juggle. The sources group these into four main categories, which seems really helpful for getting a handle on it all.
Yeah, it's a good way to break it down. So first up, you've got functional hardware profiles. Like the name says, these are the workhorses, designed for specific mechanical tasks, things that are essential for the system to operate smoothly, safely.
Okay, like what kind of tasks?
Think heavy-duty sliding tracks, maybe for machine guards, or complex locking channels that secure big access panels. Even things like cable management profiles, the ones that route and protect wiring inside automated machinery. If it's moving constantly as part of its job, it probably fits here.
Got it. Okay, then the second category is a bit different. Decorative hardware profiles. These sound more about looks, but you mentioned they have a dual role, right? Aesthetics and protection.
Precisely. You see these a lot as edge trims or maybe frame covers on high-end windows, doors, furniture. They definitely enhance the look, give it that polished finish. But their job doesn't stop there. Once installed, they're taking the hits, protecting the main structure from daily wear, bumps, impacts.
Right, protecting the edges. Okay, what's number three?
Number three is absolutely crucial for modern manufacturing. Assembly hardware profiles. These are the connectors, the joiners. We're talking about things like custom brackets, specialized hinges, joining profiles designed to lock modular units together securely.
Ah, the things that hold it all together.
Exactly. And their importance. It's huge, especially in manufacturing. They don't just guarantee structural integrity, they massively simplify assembly. Using the right joining profile can make putting together complex modular systems way faster, way easier. Big savings on time, labor, even maintenance later on.
Okay, makes perfect sense. And the last one, the most specialized.
That's custom engineered profiles. This is where you go when nothing standard, nothing off the shelf quite fits the bill. Maybe the performance needs are extreme, or the design integration is really unique and tricky.
So this is for the really bespoke applications.
Right. The goal here is perfect compatibility, optimized performance for that specific task, and just seamless integration. And usually this means you're working really closely with the manufacturer, someone with experience, like those examples mentioned in Gujarat or elsewhere in India. They often help with the design, the prototyping, getting it exactly right from the start.
Okay, that structure really helps clarify things. Let's pivot now to the actual selection. If you, our listener, need to source one of these critical profiles, what's the checklist? What are the, say, 5 key things you absolutely have to get right?
Okay, first and foremost, application requirements. You have to nail down exactly what this profile needs to do and what stresses it will face.
Yeah.
Is it part of a sliding mechanism? Then you need top-notch mechanical strength and, crucially, wear resistance.
Right.
Is it mainly holding a static load? Then the focus might be more on resisting continuous stress or pressure without deforming. The function dictates the engineering.
And tied right into that is factor 2, fit and compatibility. You mentioned this earlier, but let's talk consequences. What happens if the fit is just slightly off?
Oh, the consequences can be immediate and, frankly, expensive. A small misfit. That can be huge delays during assembly. People wrestling parts together, maybe even having to modify things on site.
Yeah, wasted time.
Exactly. And worse, it compromises the whole system's lifespan. If a profile doesn't mate perfectly with its fasteners or locks or the next profile, you introduce stress points. Things wear out faster. Reliability plummets. It's a whole ecosystem. One bad fit affects everything.
Okay, so fit is critical, which leads us, I guess, straight to number 3, profile dimensions and tolerances. You said precision is key.
I really can't overstate this. We're not just talking about getting the measurements roughly right. The tolerances are everything.
How tight are we talking?
It depends on the application, of course.
Yeah.
But often it's fractions of a millimeter. Especially for anything high speed or systems needing a perfect seal, like an HVAC or medical devices. Even a tiny deviation outside that tolerance can mess up efficiency, or worse, safety. Getting those measurements spot on is what guarantees that secure, the sources call it a rattle-free fit.
Rattle-free fit. I like that. That sounds like quality engineering.
It absolutely is. If you're building something sensitive, you can't have components vibrating or shifting.
Okay, so dimensions nailed down. Factor 4 is about protecting that profile. Surface treatment. We hear terms like anodizing, powder coating. Is this just about color?
Not at all. I mean, yes, it affects the look, but the primary function is engineering. It's about durability, protection.
Oh, okay.
These treatments add a protective layer. Anodizing is great against corrosion. Powder coating can be excellent for resisting scratches and impacts. Brushing gives a certain look, but also can hide minor wear. The choice depends entirely on where this profile is going to live and what it's going to face.
Which brings us neatly to number 5, environmental conditions.
Exactly. You have to consider the environment. Is it going to be exposed to constant moisture, maybe salt spray near the coast, or extreme temperatures, harsh chemicals in an industrial setting, abrasive dust?
So you can't just spec aluminum. You need the right aluminum alloy for the job.
Precisely. Different aluminum alloys have different strengths. You know, a 6063 alloy is common for architectural stuff. It looks good, it extrudes well. But put that in a marine environment or somewhere with aggressive cleaners, and that might not last. You might need a 5XX series or a 661 with the right treatment. Matching the alloy and the surface treatment to the environment is critical for long-term performance. You can't skimp here if the conditions are tough.
Okay, that checklist makes a lot of sense. Application, fit, dimensions, surface, environment. Got it. Now let's see how this plays out. Where do we see these specialized profiles making a real difference in the real world? The sources gave some great examples, starting with machine manufacturing.
Oh yeah, absolutely.
Okay.
In any kind of automated or complex machinery, these profiles are everywhere. They form the protective guarding that keeps operators safe. They act as those integrated tracks for managing bundles of cables and hoses.
Right, keeping things tidy and protected.
And precision mounts for sensors, that's huge. Getting sensors positioned exactly right is critical for automation. Plus, you see them in operator control panels, making them robust but also ergonomic. They really boost reliability, but also make maintenance access easier and safer.
Okay, shifting gears a bit, what about architectural hardware? This is where we might actually see the profiles more.
Definitely. And here, it's often that triple challenge.
Yeah.
They need strength, they need to look good, and they need to resist the weather and constant use.
Like for big sliding glass doors.
Exactly. Those tracks have to handle significant weight, operate smoothly for years, and resist whatever the weather throws at them. Or think about sleek edge trims on modern buildings, defining lines. Or handles on high-traffic doors. They need to be strong, feel good, look good, and last. It's a demanding application.
Yeah, you don't want a wobbly door handle on a fancy building.
You really don't. Another big area, and one that's growing fast, is electronics and automation. Well, everything's getting smaller, faster, more complex. Specialized aluminum profiles offer lightweight, strong, and customizable solutions. Think about mounting rails inside server racks or control cabinets. They need to hold circuit boards securely, maybe provide some EMI shielding.
Ah, shielding. Interesting.
Yeah, aluminum's good for that. And the profiles can be designed for easy assembly, maybe with T-slots for mounting components. And what's interesting, as the sources point out, is this feedback loop. Automation demands higher precision and consistency from components, which pushes the extrusion manufacturers themselves to improve their processes, tighten their tolerances. So the demand for better automation parts actually helps improve extrusion quality overall.
That's fascinating. A rising tide lifts all boats, sort of.
Kind of, yeah. The quality improvements driven by one sector can benefit others.
Okay, and one last example area. Furniture and interiors. Seems less demanding, maybe.
Functionally demanding in different ways. You see them as sleek trims on cabinets or desks, adding that modern look. But also think about pull handles or adjustable framing systems for modular office furniture or partitions.
Right, for flexibility.
Exactly. They provide the necessary structure, but also allow for design flexibility, reconfigurability. It's about combining aesthetics with practical, adaptable function.
Okay, so it's clear these aren't just simple pieces of metal.
Not at all. To wrap it up, really, choosing the right aluminum hardware profile isn't some minor detail you figure out later. It's fundamental. Getting it right means ensuring strength, making sure everything fits and works together flawlessly, and guaranteeing performance for the long haul. And that takes, a careful, detailed look at all the project's requirements.
Absolutely. We've really seen today that precision is just non-negotiable in so many cases. And maybe the difference between success and failure is finding that technical partner who really understands all these nuances we've talked about. So here's something to think about. If your performance requirements are absolute, if there's zero room for error, how much does having access to expert in-house engineering support things like help with prototyping, optimizing the design, like those manufacturers offer? How much does that change what defines a successful profile? When the tolerances are that tight, maybe the expert guidance is just as critical as the metal